Welcome and hi, my name is Nur Amira binti Ishaq from University 20% on. I want to present my innovation title, Utilization of Dark Eggshell Waste in Biopolymer Film for Sustainable Radiation Protection. I explore how dark eggshell waste, which is rich in calcium carbonate, can be used as a functional filler in a biopolymer film. The goal is to observe how this natural calcium carbonate affects the mechanical, physical, and radiation shielding performance of the film. This innovation provides an eco-friendly alternative to conventional shielding material, which are often heavy, toxic, and non-biodegradable. So instead of letting agricultural waste pile up, we convert it into a valuable, green, and sustainable. Currently, radiation shield mainly use lead, which is very effective but also toxic, heavy, and harmful to both health and the environment. At the same time, dark eggshell waste, which is actually rich in calcium carbonate, is thrown away in large quantity that contributing to landfill problem. And with the increasing usage of radiation in industry, medicine, and research, we need a new protective material that is safe, affordable, and environmentally responsible. So how can we solve all these problems at once? Our solution is simple but powerful. So first, we create a lightweight, non-toxic biopolymer film using calcium carbonate from dark eggshell that potentially reducing or even replacing lead in radiation shielding. So next, we take a dark eggshell waste and convert it into a valuable calcium carbonate filler that helping reduce environmental waste while supporting a circular economy. Last is this method use low cost and biodegradable material, making it affordable and sustainable for large-scale production. A simple waste product become a high-impact innovation. This project has three main objectives. So first, to produce biopolymer film using dark eggshell as a natural filler. Second, to characterize the chemical, physical, and mechanical properties of this film to understand how the eggshell influence their performance. And third, to evaluate how well this film can attenuate gamma radiation under different radiation sources. So our objective, cover production, characterization, and radiation performance is methodology. First, dark eggshell were collected, cleaned, dried, and ground into a fine powder. This powder was then mixed with starch and glycerol to form the base material for the film. The mixture was later cast into standardized sheet and dry under controlled condition to produce uniform composite film. Next, the film were tested for tensile strength, thermal stability, FTIR functional group, SEM, surface morphology, and UV absorbance. Each test helped reveal how eggshell calcium carbonate affects the film structure, whether it becomes stronger, more stable, or better at blocking radiation. How innovation works. This diagram shows how different materials block different types of radiation. Alpha ray can be blocked with something as simple as paper. Beta rays need a thin metal layer. Gamma and X-ray radiation, which are much stronger, that normally require dense material like tea, lead, or steel. Neutron radiation is usually reduced using water or concrete. Radiation hits my biopolymer eggshell film. Some of the X-rays are absorbed by the calcium carbonate particle. Some are scattered, reducing their energy, and the amount of radiation passing through is significantly lowered. So even though my material is not as strong as lead, but it works using the same fundamental principle that shown in the diagram. This project introduced several elements of novelty. First, it creatively used dark eggshell waste as a sustainable reinforcement material, something not commonly explored, right? So second, it demonstrates significant improvement in mechanical properties such as tensile strength, density, porosity, and thermal stability. Third, it represents a biodegradable and non-toxic alternative to traditional lead-based radiation shield. This means safer material with a lower environmental footprint. This innovation provides multiple benefits. First, the film are lightweight, flexible, and practical for daily use in lab, hospital, and electronic industry. Second, it helps reduce agricultural waste, minimizing the burden on landfill. And third, it contributes new knowledge on how eggshell reinforcement affect the mechanical and physical behavior of biopolymer film. The commercial potential of this product is very promising. The film are lighter than conventional lead shield, making them easier to move, wrap, and use. Next is dark eggshell are abundantly available and low cost, that reducing production expense. Lastly, with the market now shifting towards green, sustainable material, this innovation fits perfectly into the growing demand for eco-friendly radiation protection products. In the conclusion, dark eggshell waste was successfully converted into a biopolymer film that proving that its calcium carbonate content strengthened the material. Next is characterization results such as tensile tests, FTIR, SEM, UVVs, and thermal analysis confirm that eggshell calcium carbonate enhance the film structure and stability. And lastly, the film shows potential for gamma radiation attenuation that supporting its role as a sustainable, eco-friendly radiation shielding material. This innovation transforms waste into a solution for environmental and radiation safety challenges.